Hi, in this video I'm going to show you how to solve exponential equation. Before we start solving exponential equation, let me review some of the laws of exponents, right? So if you multiply two numbers with the same base, the exponent may be anything there, but if they have the same base, then you can combine, you can multiply those two numbers with the same base as writing the single base, and then you add the exponent. Okay? And if you have a base to some exponent and then outside there is another exponent, you multiply the exponent there. So here, if the base is multiplied, then you add the exponent, but if the exponent is multiplied, you multiply the exponent there. Okay? Next is, if there is two bases multiplied together with the single exponent, then you can distribute that exponent in this case. Okay, the last one is, if the exponent is negative, you can do 1 over, you can move this to the bottom, 1 over a to the positive exponent. So to get rid of the negative exponent, you just do 1 over. But if there is this negative exponent is on the bottom, you just move that to the top and then write the positive exponent. Okay, and if there is any base, non-zero base, the a should not be 0. Okay, and 0 is in the exponent. Any base with 0 exponent is always 1. So these are the laws of exponent we saw before. Now we want to use these laws and then solve an exponential equation, right? So the basic idea to solve an exponential equation is, what we do is, if there are any bases in the left side or any number of bases in the right side, what you try to do is you try to combine the left side into a single base. Okay, and you try to combine the right side into a single base, and then you try to get like a to the some exponent and then a to the other exponent, like that. And after you get this, what you do is you cancel that a and then write u equals to v and then solve it. Okay, so for example, here on the left side there is just two, base is 2, there is only one base, that is 2. On the right side there is only one base, that is 2 again. So we have the left side and the right side have the same bases, and there are only one basis, right? So in that case, what you can do is you can cancel that 2 and 2 and then write x equals to 6 is the solution here. Make sense? Okay, here there is 3 on the left, that's the base, and on the right the base is 3. You have only one base on the right, left, only one base on the right. So single base there, and they are equal, so you can cancel those. Right? So what do you get? You get x squared equals to 4. But you want to solve for x though. So let's solve for x. What do you get? Take the square root on both sides. But when you take the square root, you consider plus and minus sign, right? So you get x equals to plus minus square root of 4 is 2. That's what you get. So x equals to plus minus 2. Let's take another example. You have 2 to the y squared equals to 16. So here in these examples you had the base on the left and base on the right were same, but here the base on the left is 2, base on the right is 16. You cannot cancel 2 and 16 there. You cannot even divide by 2 on both sides. No, you cannot do that. So what you try to do here is try to write 16 as the base 2. So what raised to the 2 is 16. So 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 2 times 2 times 2, that is 8, and 2 to the 4 is 2 times 2 times 2 times 2, that is 16, right? So you can write this as 2 to the y squared equals to 2 to the 4, right? Now see, you have the same base on the left and right, and there is just only one base on the left and only one base on the right, so you can cancel those two. Okay, so what do you get? So you get y squared equals to 4. And again, take the square root. When you take the square root, you consider plus minus. So you get y equals to plus and minus 2. That's what you get as an answer there. Make sense? Next is this one. So the base in the left is e, base in the right is e, but there are two bases, 2e. So you want to combine them into a single one. So let's use the first one. See, if you have a to the x times a to the y, you can write a single a here, and you can write single e and then add those exponents. You can write x plus 2 plus 3. That's what you can do. On the right side you have e to the 7. Okay, so see, there is only one base on the left, only one base on the right, like that, and then there are exponents there, so you can cancel those bases there. Make sense? Now what is x plus 2 plus 3? It is x plus 5 equals to 7. How do you solve for x? Subtract 5. So you get x equals to 7 minus 5 is 2, right? X equals to 2. That is the final answer for this. Let's say this one. So there is e to the x squared, e to the 7 minus 5x, and then there is 1 over e. Okay, so how do you solve this? So first of all, you combine the base on the left and you write the base of e there. So e to the x squared, you can write plus 7 minus 5x equals to, since this e is on the is in the bottom, there is like e to the 1, and you want to move this to the top to compare. See that a, both of them are on the top, not on the denominator there, right? So you want to get that from e to the negative 1. When you move these to the top, that 1 will change the sign, that exponent 1 will change the sign. Now you have this form, right? There is a single base e on the left, single base e on the right, so you can cancel those. What do you get? You got x squared minus 5x plus 7 equals to negative 1. Make sense? Now how do I solve? This is a quadratic equation, right? So to solve a quadratic equation, what you do is make the right hand side 0, add 1 on both sides. So what do you get? You got x squared, correct, and then minus 5x plus 8 equals to 0. Make sense? Now what do? This is a quadratic equation. Now use the quadratic formula. So x equals to minus b plus minus square root b squared minus 4ac divided by twice a. Okay, so what is b? B is negative 5. So here a is 1, b is negative 5, c is 8. Okay, so negative 5 plus minus square root negative 5 squared minus 4a is 1, c is 8, divide by, what do you get? 2 times 1. So this will be 5 plus minus square root 25 minus 32, right? Divided by 2, because negative 5 squared is negative 5 times negative 5. So that will be that. So what do you get? 5 plus minus square root of negative 7 divide 2, right? So this will be 5 plus minus square root of 7i, because square root of negative 1 is I, divide by 2. So these are the solutions. Let me take a couple more examples on this, okay? The first, the example 6 is solve 2 to the x squared minus 7 is equals to 8 to the 2x, right? And again, there is a base 2 on the left, but there is a base 8 on the right. So you want to make the same basis, right? So it is easy to change 8 as the base 2, right? So it is 2 to the x squared minus 7 equals to 2 to the third is 8, and then there is 2x in the exponent of that, right? So what do you get? You got x squared minus 2 to the x squared minus 7 equals to 2 to the 6x, because 3 times 2x is 6x. What we did is we multiply the exponent here, right? So what do you get? You basically cancel those bases. So you got x squared minus 7 equals to 6x. So this is a quadratic equation, right? So in the quadratic equation, the idea is you want to make the right hand side 0. So you subtract 6x, subtract 6x, subtract 6x. What do you get? You got x squared minus 6x minus 7 equals to 0. Can you get the two factors for this? So x minus 7 and then x plus 1 equals to 0, right? So when you multiply, you got negative 7. When you add, you got negative 6. Okay. So what are the values? You said x minus 7 equals to 0. You got x equals to 7. If you add 7 on both sides, you got x plus 1 equals to 0. Either this equals to 0 or that factor equals to 0. Subtract 1, you will get x equals to negative 1. So these are the solutions for x here. Next is solve. So here on the left side there is 8, base 8. On the right side the base is 16. So can you change 16 as base 8? Let's try. So what is 8 to the 1? Is 8. 8 to the 2 is 64. So 8 to the 2 is not 16 because 8 to the 2 is 8 times 8. It is 64. So you can write 16 as base 8. You cannot. So let's go down and then let's try to write 8 and 16 with some base. Can you write both of them as a base 4? I don't think so, because it is 4 to the 1 is 4. 4 to the 2 is 16. So you can write this as 4 to the 2, but you can write 8 as 4 to the 4 exponent of 4. So what you try to do is, let's try to write all of these with base 2. So what raised to the 2 is 8. That's right, that is 3, right? So you write 2 to the 3 negative x plus 4 equals to 2 to the 4 is 16. There is x. Okay, so what do you get on the left side? It is, you multiply these 3, you distribute that 3 to both of those, right? You write 2 to the negative 3x plus 12, because you distribute that 3 to both of those exponents, right? And then 2 to the 4x. That's what you get there. Okay, so now you have only one base 2, and the left hand side, left and right, and then they are both equal. Now what you do is you solve it. So you got negative 3x plus 12 equals to 4x. So how do I solve it? You add 3x on both sides. You will get, so that will cancel. So 12 equals to 7x. Divide by 7. So x equals to 12 over 7. That is the final answer for this. Okay. Now the final example is, if you have to find 2 to the negative 3x if 2 to the x equals to 3. Okay, so what is given? Let's write down the given thing first. 2 to the x equals to 3. Now you want to find 2 to the negative 3x. So how do I get 2 to the negative 3x from 2 to the x? That's right. So you need to raise negative 3 power on both sides. Because on the left you will get 2 to the negative 3x because you multiply these two, right? So 2 to the negative 3x equals to 3 to the negative 3. How do I find 3 to the negative 3? So since it has negative exponent, what you do is 2 to the negative 3x is in the left. You can write 1 over 3 to the positive 3. Right? So how much is that? 1 over 27. So the value of 2 to the negative 3x is 1 over 27. Okay, thank you guys.